Hi and welcome. Thank you for joining us. My name is Mudit Saxena. I am the CEO and co-founder of XeroHome and Vistar Energy.
And I'm Peter May-Ostendorp, CTO and co-founder at Vistar Energy and XeroHome.
And today we're going to be talking to you about electrification retrofits at scale, the strategic advantages of scaling analysis from the individual to the collective. We're very glad that you took the time to see our presentation. Hopefully you'll also read our paper. So let's get started. So the first slide we want to talk to you about is the massive opportunity that exists with existing buildings and retrofits with existing buildings. And then within that, the single family residential. So the graph you see is from REX and CBEX. This is the building energy consumption data. And the one big thing that comes out at you is single family residential buildings consume about 47% of all energy consumed by buildings. This is existing buildings, and this is the opportunity we need to, if we're serious about our goals for greenhouse gas emission reductions, we have to be targeting single family residential buildings and existing buildings in general. So existing buildings are key to also decarbonization. Studies have shown that about 25% of greenhouse gas emissions are attributable to buildings in California, and this should be true for other states as well. And almost 90% of homes use gas for heating their space and heating water. So these 90% homes that are using gas equipment are great candidates for switching fuels from gas to electricity, which is a much more cleaner fuel and in future gets even cleaner. So that's really the target, and to be able to get to those is going to be the most important goal going forward. So if you want to do that, if you want to really reach these homes, the question that we need to ask ourselves is electrification cost effective for these homeowners that we want to go and change their heating systems and water heating systems with? So if you look at a home, they typically pay utilities for gas and electricity. So if you have a home that has gas equipment and you're replacing that with an electric unit, the question then becomes, have you done, are the bills going to be lower, and will they be able to pay for the capital cost of this new equipment? So the question really is, can that be done? And when you look at the math, it really gets very interesting, because heat pumps are about 2 to 4 times more efficient than gas units, but they use electricity, and you're displacing gas, and gas as a fuel to deliver energy to a home is cheaper than electricity. And if you look at data from DOE, which is this graph on the right, which plots the ratio of electricity to natural gas prices, you're looking at about 2 to 6 times more expensive, electricity about 2 to 6 times more expensive. So it's very interesting, because you have 2 to 4 times more efficient unit, but it's using a 2 to 6 times more expensive fuel. So will it work out, and what are the factors that determine if the cost effectiveness stands or not? So if you really look at this question, we've been doing some work on this. We've realized is that electrification cost effectiveness depends on several factors. A big one is what we just talked about, which is this disparity between electricity and gas prices. But also it depends upon the home itself, the age, the efficiency of the existing unit that you're replacing plays into that cost effectiveness role. The existing envelope of that building matters. The weather and the location where that building is plays a huge role in determining how much that equipment is going to be used and whether it will be cost effective over its lifetime. Other factors that are listed here also play important roles. So really what we're trying to make the point here is that the answer can be different from one home to another. And really there's no one size fits all solution. So that's unfortunately the answer. So when you're faced with this, sort of one way to think about it is, how do you solve this problem and how do you do it at scale? One way to do that is with energy assessments. And they're a great, detailed, and very accurate way of doing this, but they're not scalable. They cost a lot of money. You have to send someone to physically be at a home to do the energy audit, and that's not going to scale very well for large populations. So the way we think about this is that the key to crack this is data and scale. I'm going to borrow a term called epidemiology from medicine, which is a study of distributions of patterns of health conditions in populations, and we can apply that same thinking for buildings. When it comes to buildings, the good news is that there's a lot of great data out there. You can start with property assessment data. That tells you the age of the building, the square footage of that building, number of bedrooms, bathrooms. That's available for every single home in the country. Add to that, and that information can just be used to infer some idea of what the existing efficiencies of the envelope as well as the other equipment could be. Add to that property building permit data, which is also collected and is available. It is in public domain. That can tell you when a large equipment like an HVAC system was replaced and the year that that was done. And then you can add to it the 3D geometry of homes that are also available, and you can use that information to determine what's the solar potential of a particular home. So you can have all this data and you can kind of add that together. So our thinking at XeroHome is that we can take all that data and put together this data to build an energy model for every single home. So you can take property assessment, building permits, 3D geometry, and even demographics data. And if a homeowner allows us to use energy use data to build energy models, which can even be calibrated energy models, then with that energy model, we can provide some great analysis that can determine if certain measures are cost effective or not. So XeroHome is a web-based tool that we have developed. It has an output, which is also a web-based output. It kind of looks like this. A homeowner can type in a home address and they are given recommendations about what works for their home. They're given a very simple to read diagram, which is colorful and easy to understand. Each segment of this colored diagram from left to right is an energy efficiency measure. If it's cost effective, it's recommended first, so it's towards the left. If it's not cost effective, it gets recommended towards the end or towards the right. And together they make up a plan or a path to get to a goal of net zero energy or net zero carbon for that home. So once you get a homeowner and once you present them this information, you can also start sort of a collaborative process with them in which you can ask them some questions and you can say, hey, fill out a questionnaire for us, give us some more information. And the reward for that is that as soon as you give us more information, you get a better recommendation right away. So it's very interactive. And to encourage the homeowner, we give them some badges like white, green, and blue, which allows them to continually give us more information with site observations from their own home. So that becomes sort of the model that we work with, and we allow homeowners to give us more and more data. So at the end of the day, this process that we've built with XeroHome is extremely scalable because it's mostly automated. And so we can build, if we can do this in one home, we can do it for thousands of homes together for an entire city or an entire region. And what Peter's going to talk about in the next few slides is our project with Southern California Edison. We did a project with for the city of Santa Monica, supported by Southern California Edison's ET, or Emerging Technologies project. And in this, we applied the XeroHome tool and methodology to really solve this problem of trying to find out how we can scale electrification in this city. So, Peter?
Great, thanks, Mudit. Yeah, so if we could take a look at the next slide, we've got a now familiar map of the city of Santa Monica. Santa Monica, as you know, Southern California, wonderful sunny climate. Lots of single family homes there, about 8,200 for us to work with. The map shows you the diversity of ages represented in color and of sizes of these homes, which are basically the size of the dot. We've got everything from smaller, sort of turn of the century bungalow type places all the way up to brand new mansions effectively built along the golf course. So a pretty diverse building stock to work with. What we're doing, what we're presenting to you today is phase one analysis of the city that we did. This is prior to actually releasing the tool to homeowners. So we haven't yet received homeowner input. This is just what we've been able to do with the rich public data sets that we have access to. And to give you a sense of some of the results, to just show you a couple different individual homes just to give a flavor. So here again is the path to zero diagram that it was showing you earlier. And these are results for a home from 1926, about 1,700 square feet. It uses gas for its heating, and it had a new roof put on in 2017, but otherwise we haven't detected a whole ton of recent updates to that building. And so as you can expect, there's a lot that can be improved there, is what we would suspect. So everything from lighting to ceiling insulation, even some wall insulation improvements, and so on. Now, a couple of things to note. What you will notice happening, and this is the electrification dynamic that we spoke about earlier, is that toward the left-hand side of the diagram, you have the most cost-effective things. And lighting, not surprisingly, is one of the first things you should be doing. Most people would know, but then interestingly, solar shows up even before a lot of energy efficiency measures, and people might scratch their heads, but in Santa Monica, and with the TOU rates structure in place, and the gas pricing in Santa Monica, this really makes a lot of sense. We have relatively high TOU rates, and anything you can do to shave your electricity, especially on peak, is going to make a lot of sense. So rooftop solar is a very cost-effective measure there. The electrification measures, somewhat to the contrary, fall to the far right-hand side of the diagram, meaning they're the least cost-effective, but they're also essential to getting all the way across the board to zero and fully decarbonizing this home as well. So heat pump, water heater, and air source heat pump both factor into that plan. Now, if you look at the next home, this is somewhat intuitively a little bit sparser, because this the recommendations for this home, this is a home built in 2013, a lot newer construction, and not a whole lot of opportunity for many of the energy efficiency upgrades. However, there is still a big decarbonization benefit from electrifying, and you can still see those showing up. You know, if you still want to get this home all the way to zero, you're going to have to do those electrification measures. But again, not very cost effective, especially when compared to options like solar. So we saw this pattern coming up again and again as we surveyed across our cohort, our initial cohort of about 1,000 homes. We're going to be going to all 8,000. But what we see is electrification measures didn't produce positive net present value, didn't actually produce cost-effective savings on their own in this particular climate and in this particular economic environment. And it's the rates. It's definitely the disparity between electric and gas rates. It is also the climate. It is the mild climate, and there's very low heating and cooling loads in Santa Monica, and so heat pump HVAC isn't netting you as much savings as you might get in some other regions. Rooftop solar, on the other hand, super cost effective for reasons we described, and it's beautiful, sunny Southern California, so not too surprising. Interestingly, there's almost not really a single home in this set that could get all the way to zero or to deep decarbonization without these heat pump upgrades, despite the cost effectiveness. So they keep showing up as recommendations. They're just kind of, save these for later. So we keep thinking, well, what can we do to make more of that happen now? We need that rapid transformation to start happening. So we started looking into the concept of bundling, and looking at the economics of electrification and solar when they're considered as a bundled installation. So we took this approach. Here's an example for a home from 1948, very similar to some of the ones you've seen so far. It has a recommended solar rooftop installation of about 3.7 kW based on our analysis of its roof and its exposures. So we're going to show you a sequence of some resulting from, well, here we're going to start with the base case for that home. So this is what we, roughly what we think just out of the box the utility bills could look like. So gas is in orange, the electric is in blue, and you're seeing the stacked bars represent the amount of energy in kBTUs per year consumed in each of those fuels. And you'll see in the numbers are the cost of each of those fuels. Now, you'll see that the cost for electric, even though it makes up maybe, a third of the total energy use, is, it's basically inverse. It's about, it's more than 2/3 of the cost. So now, what happens when you install an electrification measure in a home like this? Well, so naturally, there's big savings in gas, right? We've just cut out gas water heating, but there's a bump in the electric bill, and actually so much of a bump in the electric bill that the overall bills, you're actually not netting any, at least in this particular home, we would estimate you're not netting any bill savings from that electrification measure. So not surprisingly, the economics look pretty poor. However, if you look at this as a bundle where you're doing solar plus electric water heating, and you combine these two measures together, the overall economics actually look relatively favorable. So taken together as a measure, you can save about 2/3 of the total energy use in this home, deeply reduce the gas, and of course with the solar / the electric pretty significantly as well. You come out with utility bills that are 2/3 less, or maybe even 70% less, and a pretty healthy 7,000 net present value over the period of this. So that's kind of what we're seeing with the bundle across the board. I'm going to show you next. We took a look not just at this particular bundle, we looked at a variety of different bundles. And in this chart, you're seeing results in a box whisker that span all 1,000 homes in this cohort. So we looked at the heat pump water heater electrification measure on the far left just on its own. The spread is basically the spread in net present value for that measure as installed in these 1,000 homes. And then you're looking at bundled versions with bundled with ceiling insulation, weatherization, radiant barrier, lighting, and then solar, which really sticks out on the far right. What you can see is that for most efficiency measures, the net present value, the homes that come out positive in terms of the economics and positive net present value are really, they're really the exception to the rule. Whereas with solar, it's, by far they're in the majority, and the vast majority of homes are going to come out with a very healthy net present value. But there are still a few that don't make it. And what we found is this basically it's strictly a function of the array size that your home is expected to accommodate. And so somewhere around, this chart shows roughly, your net present value of the bundle versus the size of the array that you install. And as you get down to homes that can't accommodate very much solar, about 1.5 kW or less, you start getting very negative net present value. So we found that for a safe margin, for homes about 3 kW and above, which by the way would be most of the homes we would analyze in Santa Monica, this is a very safe and cost-effective measure to be installing. So overall, this started to get us thinking about, well, what could we do with this to actually encourage this sort of bundling? Solar plus electrification bundling could be the next kind of frontier, next consideration in REACH codes. This could be a requirement that's triggered at the time of permitting for solar installations. And so what would happen, you pull a permit for solar, depending on some other criteria related to your home, for example, how old your existing water heater is or something like that, you might be required to retire that equipment early and install a heat pump water heater. That could be what a bundle looks like. And what this would do is, of course, greatly accelerate the pace of electrification retrofits in the residential sector, which is something that we really have to do to keep up with climate goals, is that in that market transformation component. So this REACH code concept was presented to Santa Monica itself. Some of the city staff have taken a look at it, but it hasn't been formally endorsed or considered at the city council level or anything like that. So that's where we stand. But exciting, exciting possibilities with that. So overall, the economics of electrification, as we've said, highly dependent on the local conditions. To get it right, you really need to look at everything from the utility rates, the individual home equipment efficiencies, the climate, available rebates, et cetera, to get a full picture of this. This bundling approach has really identified a way to combine electrification with other more cost-effective measures, in areas where electrification on its own would be challenging, and to put together a package that actually works economically for everyone. What you need in order to do this is you need to do some fairly detailed analysis to be able to compare all the different combinations of measures and how they bundle, and to gain some confidence in terms of the sensitivities. What we were able to do here is to really examine across a building stock, so you get that diversity of inputs. As far as getting to this individual case-by-case analysis, we really feel that style of analysis is going to be critical to building confidence and promoting more aggressive electrification. And it kind of, it underscores approaches that take advantage of that uniqueness in the building stock. And I think also, to be fair, one of the things we'll be doing in future phases of this emerging tech project is bringing this tool to homeowners and gaining their input on the actual situation on the ground with their homes. And that will further build confidence that specific electrification projects can be installed, that they are installable, that they will be a good value for the homeowner, and so on. And so that's kind of building a bridge from both sides there. So thank you again for your attentiveness, and we really do hope that you reach out to us with any questions you have about our work with SCE and Santa Monica, or XeroHome in general. And of course, please do read the paper.
Right, thank you very much, and good luck with the rest of the conference. We wish you all the best. Bye.